Okay, this is for the packet factoring polynomials. Our problem here that we're presented is x cubed minus 216. We're asked to factor x cubed minus 216 and then choose the answer in its factored form. All right, so it helps to know your special case polynomials really well. So we'll do a brief review of special cases right here. Special cases. Okay, the first one we're going to look at is difference of squares. Okay, so say you were asked, say you need to know how to identify them also. So say you had a problem like x squared minus 49 and you're asked to factor this. You'd have to recognize that that's a difference of squares. So the minus sign is where the difference part comes in, and then x squared is a perfect square, and so is 49. Okay? So take the square root of both, and you get the square root of x squared is x, the square root of 49 is 7. Okay? So when you factor x squared minus 49, you're going to have two factors. You're going to have x minus 7 times x plus 7. Okay, and that's how you do a difference of squares. Then we also learned about difference of cubes. And that's what our problem up here is, a difference of cubes. Okay, so if you have a problem like x cubed minus 216, which we have, okay, it's going to follow a pattern. We need to get an a and a b, so you take the cube root of x cubed, and you get x, and you take the cube root of 216, and you get 6, okay? And then difference of cubes is going to be a binomial times a trinomial, so the second set of parentheses should be a little bigger. Okay, the x and the 6 is going to go right here. And then let's figure out our signs. So we learned same, opposite, always positive. So same would mean, okay, if we have a minus sign in our original, then we're going to have a minus sign here. And then the opposite of minus is plus, and then this one's always going to be plus. And then if you look at your answer choices, you can immediately cancel out A and B. Okay, so that helps a lot. But the other thing is square smash square. Okay, so we're going to square our x and get x squared. Then the smash part is 6 times x, which is 6x. Okay, and then you square the 6 and you get 36. So now we have our answer, which is D. Okay. For further review, we also have sum of cubes, which looks just like difference of cubes, except there are a few slight differences. So a sum of cubes could be x cubed plus 216, or 8, or 27. Okay, those numbers that are perfect cubes. Let's just use 216 again and show how similar it looks. When you factor this, you're going to have the cube root of x cubed is x, the cube root of 216 is 6, and it's going to factor like this. Okay, another binomial times a trinomial. And then we'll have the x here, the 6 here, and then same, opposite, always positive. So plus, for same, we're going to have a plus there. The opposite of that is minus, and then this one's always positive. Okay? Then square smash square. So again, you're going to have x squared, you're going to have 6x, and you would have 36. Okay? So that's if you had a sum of cubes. So you want to know your special cases. All right? The one that we were looking at in particular was difference of cubes, okay? But you know, you might on your SOL get a difference of squares or a sum of cubes, and you want to know how to factor those. Okay, so one last thing I want to show you is we've been talking about how you can use 2 in place of x when there's only one variable. Okay, well, we only have one variable here, x, right? And then all of the answer choices have x's in them. So you're going to put a 2 in to the original problem. And let's see how this could work, okay? So if you forgot how to factor, this would be a great strategy to use. So let's find out in the original, okay? Let's just use 2 in place of x. Here's the next strategy. If you forgot factoring, or forgot how to factor. Okay, so let's put it, you had x cubed minus 216. All right, and we said we're going to use 2 in place of x. So when you do that on your calculator, okay, 8 minus 216 gives you negative 208. Let's find out, you know, if you put it into the first answer choice A, you had 2 minus 6 cubed, okay, do that on your calculator, what do you get? Negative 64. Okay, is that negative 208? No, so cancel that out, okay? Okay, let's try the other one. Yeah, we're going to replace x and x again. We're going to use 2. So 2 minus 6, parentheses, 2 squared plus 36. I'm using parentheses to be really careful. And you get negative 4. So you guys can do this quicker on your calculator. You get negative 160. Is that equal to negative 208? No, so cancel that out. So hopefully you guys see what I'm getting here. You would also want to try answer choice C and see what you get, but D is going to be the one that works. So let's skip down to D. Okay, let's say you have 2 minus 6 times 2 squared plus 6 times 2 plus 36. All right. So check it out. When you use 2 in place of x, for answer choice D, you should have gotten negative 208, right? So answer choice C would have given you something else. Let's see what that was. Had you used 2 in place of x in answer choice C, you would have gotten negative 256. So check it out how D is the only one that gives you the matching response. See? When you use 2 in place of the original problem, 2 in place of x in the original problem, you got negative 208. When you use 2 in place of x in answer choice D, you got negative 208. So that's a great strategy to use for factoring. This one is a problem that you're going to have to factor using good old-fashioned factoring. So the first step of factoring is always to take out the greatest common factor, if there is one, and then look at how many terms you have. This is not one of the special cases that we have, but let's look to see if there's a GCF or a greatest common factor here. You have an 8, an 18, and a 5. Okay, so there are no numbers that go into 8, 18, and 5. Then you have x squared, xy, and then y squared. So they don't all like each term. One term has an x squared, then you have an x. Okay, well they have something in common, but then this one has a y. The first term didn't have a y. So you don't have a greatest common factor here. Okay, so we then see that we have 3 terms. So it's a trinomial. It's not one of our special cases, is it? No. The a value is also 8. And this is also one that's, you know, you're asked to choose the 2 factors that belong in the box. So you can play around with all of these until, you know, you multiply 2 of them and you get 8x squared minus 18xy minus 5y squared. That wouldn't hurt, okay? Just think of all the different combinations that you could use to get 8x squared. That's the first term. So if you're going to choose x plus 5y, you would want to match that up with 8x minus y, because x times 8x would give you 8x squared. If you're going to choose 2x minus 5y, then, well, you have to ask yourself 2x times what is 8x squared? So if you're going to choose this 2x, then you would want to try either 4x plus y. If that doesn't work, then you'd want to try 4x plus 5y. So you can easily just play around with these and multiply different combinations together until you get 8x squared minus 18xy minus 5y squared. But that might take a lot of time. Not to say that you don't have all the time in the world, but you know, and I have no problem if that's what you want to do. I think it's a great idea to play around with those. But in the end, let's go ahead and factor this one the way we learned it in class. Okay, so 8x squared minus 18xy minus 5y squared. So I'm going to have to use slide and divide here. So I'm going to take the 8 and multiply it to the negative 5. It's going to give us x squared minus 18xy minus 40y squared. And then you can use y equals, okay? And we're going to put negative 40 over x. And we're going to then put negative 40 over x plus x. So remember how we learned in class how to factor a trinomial? That y squared at the end, it's a little different from what we've seen in class, but that's just thrown on there, as an extra. Don't worry about it too much, okay? Y times y is going to give you that y squared later on. But anyways, we're looking for the numbers that multiply to give us negative 40 and add to give us negative 18. So when you go into your table, you have x, y, and y. You're looking in the right column for negative 18, your middle number. You look for that in the right column. Okay, so you go to y equals, put negative 40 over x, and then y equals, put negative 40 over x plus x. Let's see. Go to your table, and we look for negative 18 in the right column. So if you're not sure how to do that, raise your hand and it'll show you. But you're going to see negative 20 and 2. Okay? So that means that our factors are going to be x minus 20. Well, we're not done yet, but x minus 20. Since there's a y squared, I'm going to put a y there. And the other one's going to be x plus 2y, so there's the other y here. But then, since we multiplied by 8 originally, you have to divide this by 8 and divide this by 8. You reduce the fractions. So let's do that, x minus 5 over 2y. And then you have x plus 1 over 4y. Okay? And you're not allowed to have fractions. You got to move the denominators back in front of the x. So this is going to become 2x minus 5y. There's one of our factors. And the other one's going to become 4x plus y. So, this isn't the easiest problem. But the nice thing about algebra is you can always check your work, and you can use that to your advantage on problems such as this. So these are the boxes that you would drag. So I don't want that to confuse you. The boxes that you would drag would be 2x minus 5y and 4x plus y. Okay? If you were to multiply 2x minus 5y times 4x plus y, you would end up with your original problem. So again, you can play around, focus on the 8x squared and the negative 5y squared when choosing your factors. And that'll be a big help, okay? But that's probably one of the harder problems on the SOL, and if you can get down slide and divide, or if you can use another one of the strategies to come up with the right factors, then you're in really good shape. But don't get too down if you're having trouble with this. Just keep working on it. And there are tons of different types of problems. So if there's one problem that you don't get, it's not that big of a deal, is it? So keep trying your best to get this, and we'll come around and help you out. Good job.